Hello everyone. The science experiment we're going to be going over today is heat energy solutions involving popcorn. So everybody likes popcorn as a favorite snack, but what we're going to do today is go over how when we soak popcorn kernels in certain solutions, we're going to find out what effect that has on the speed or the rate at which they pop. So let's go ahead and move on here to our hypothesis or question statement. So what we're looking for is what is the effect of the type of solution the popcorn kernels are soaked in on how long it takes for the popcorn kernels to pop. So that's what we're going to be looking for and going over in our experiment here. Outcome statement. So what I predict is going to happen, what I think is going to happen is that using my judgment on previously with things I've cooked before, I think things cook a little bit better and faster in vegetable oil and maybe butter. So what I'm going to do is I'm going to say that the kernels are going to pop faster in the vegetable oil, then second is going to be the butter, and lastly they're going to pop the slowest in the salt. So that's what I'm going for here in my outcome statement. Content statement. So what is the science concept examined in this experiment? So this is all about solutions, heat energy, and how they affect at the rate things cook, or in this case, how fast popcorn pops. So we got some key vocabulary we want to go over. So heat is the quality of being hot or at a high temperature. Heat energy is the result of the movement of tiny particles called atoms, molecules, or ions in solids, liquids, and gases. The rate is the measure or quantity, frequency, typically one measured against some other quantity or measure. So for this particular case, rate is going to be the speed at which the kernels pop. Measurement is the size, length, or amount of something as established by measuring. So we're going to be measuring out the amount of solution we're using. We're going to be measuring out the amount of kernels we're using in the experiment. And lastly, solution is the liquid mixture in which the minor component, the solute, is uniformly distributed within the major component, the solvent. So for solutions here, we're going to be using the salt, the vegetable oil, and the butter as our solutions. So moving on, keeping on with the content statement. So how does this science concept apply? So knowledge of the science concept is crucial to the investigation. If you don't have knowledge on the concept, you're not going to be able to understand why the investigation works. So we need to know heat and heat energy. Heat and heat energy are going to make it possible for the kernels to pop in the first place. Without heat, without energy, and without a source, we're just going to be eating crunchy kernels, which I don't think anybody really likes to do. The rate at which the kernels pop, so that's very important to this experiment as well, because we're going to need to time out the rate at which the kernels pop to be able to collect our data. And lastly, measurement. So we're going to want to measure out the amount of kernels, how long it takes for each kernel to pop. It's important because if I do one run with 50 kernels, and I do one run with 2 kernels, obviously the 2 kernels are probably going to pop faster than all 50 kernels, so the data can be skewed a little bit. So measuring is going to also be crucial. So variables. So the variables we're going to use. The manipulated variable. So the variable that's going to change is the type of solution the popcorn is soaked in. Again, for this experiment, we're using salt, butter, and the vegetable oil, which we all have right here. We've got the salt, we've got the butter, we've got the vegetable oil. The responding variable. So the time it takes for the kernels to pop, I'm just going to use my Fitbit timer, or a phone timer would work, or an actual timer to go ahead and assess the rate at which they pop. The constants, so the things that are staying the same. So the same type of kernels, we're using Orville Redenbacher's original kernels all the way through. The amount of kernels, we're using 20 kernels on each run that we're doing to keep it constant, keep it simple. And the same temperature on the stovetop, we're going to set it to the same setting. My setting is medium. With most stovetops, that's about 300 degrees. So we're going to go ahead and keep all of that constant. So next is our materials, and as you can see, I have some materials laid out here. You're going to need A measuring cup, you may not need it to measure the solutions, but it's good to have. You're going to have your salt, like I said. We're going to have our butter, vegetable oil. We're going to use our Orville Redenbacher's kernels. You're going to have the pan to use to heat it up, a pan top, and the stove, of course, to go ahead and get the heat from it. So those are all of our materials. Next, the procedures. So what we're going to do. So the first thing we're going to want to do in the concept is to gather the materials, get everything laid out, ready to go, and make it easy for us. Turn the stovetop up to medium heat or 300 degrees. You're going to want to make sure it's completely warmed up before you do all runs. That way you don't start too early and you're cooking the first trial at 100 degrees instead of 300 degrees and the data gets skewed. So you're going to separate the kernels. We're going to need 30 groups of 20 kernels in order to do all 3 variables 10 times a piece. So that'll give us 30 groups of 20. You're going to soak 10 kernels into butter, place them on the stove, in the pan, and then cover the top. You're going to record the time it takes for the kernels to pop, record the information on the data sheet, and then repeat 9 times. You're going to do the same thing. You're going to soak it in the salt, put it in the pan, cover the pan top, and repeat 10 times. And last but not least, you're going to do the same thing for, which one haven't we done yet? The butter. So you're going to do the butter. So just make sure you do all 3, vegetable oil, salt, butter. You're going to do 10 trials of all 3 that same exact way. Take 20 kernels, soak them in the solution, put them in the pan, cover the top, time each time it takes to come for the kernels to pop, and by doing it 30 times, you're going to have a lot of popcorn to eat, so I hope you're hungry. So you're going to record the data for all sequence, record your totals and means, which we have done on the next page. So the data, so you see our manipulated variable, the solution, so the butter, the salt, the vegetable oil. You're going to see our 10 total runs with all each second amount in seconds we use to determine how long it took for the kernels to pop. We've got our total here, and then we've got our average. So it turns out for butter, the average time it took for all 20 kernels to pop was 61.4 seconds. For salt, it took 155.3 seconds. For vegetable oil, it was the quickest there for 50 seconds average per run. So we've got some more data we can add to that. We've got our median, our mode, and range. So what occurred in the median, so the middle of our data? Order it from least to greatest, find the median. For butter, it was 58.5 seconds. For salt, it was 154 seconds. Vegetable oil, our median was 50 seconds. Our mode, so what occurred the most? We didn't have one for butter, but we did for salt and vegetable oil. 174 seconds for the salt, 51 seconds for the vegetable oil, and our range. So our difference between our highest value and our lowest value. For butter, it turned out to be 24 seconds. For salt, it turned out to be 57, and for vegetable oil, it was 16 seconds. Another way we can represent this is in the form of a graph. So we've got our title, effect of type of solution on the popcorn. We've got our type of solution across the x-axis here. That would be our manipulated variable. The butter is in yellow, salt white. Vegetable oil is in red. We've got our y-axis title, so that's what we're measuring, the seconds it takes for the kernels to pop. We've got our scale here that goes from 0 seconds all the way up to 160 seconds. Got butter checking in at 61.4 seconds. This is the mean it took for the kernels to pop, or the average. We've got at 155.3 the salt, and at 48 the vegetable oil. So, moving on from that one, we've got our results. So, the average time it took for the kernels to pop when soaked in butter was 61.4 seconds. The average time it took for the kernels to pop when soaked in salt was 155.3 seconds. And the average time it took for the kernels to pop when soaked in vegetable oil was 50 seconds. And as you can see, all those trials turned out to produce a lot of popcorn. I know Halloween's coming up, so don't get too scared about my face on the picture there, but the focus is on the popcorn. You're going to have a lot of popcorn to eat. So that is a very positive and maybe a kind of a reward for doing the experiment. So in conclusion, so in this experiment, I found that obviously through our data, my prediction that I made in the beginning was right. The popcorn tended to pop faster in vegetable oil. And then butter actually wasn't too far behind, but salt was very far behind. So I got my order right, but the reasoning behind it still has to be explained. So, for those of you who may not know, the inside of a kernel of popcorn is filled with starch. When exposed to the heat energy, that starch expands and pops into what we know as actual popcorn. The expansion occurs because a small amount of water in the kernel evaporates as the kernel is heated. The water expands as it is changed into a gas. And just like all gases, when they expand, when they're heated, the kernel expands and the starch inside the kernel expands and pops into what we know as popcorn. So why I think it happened, I kind of could see this in my prediction because, you know, cooking with vegetable oil, I didn't really know why, but I knew that if you put something you're cooking into a pan with vegetable oil, it's gonna cook faster and taste better than if you're just sticking a pan on the stove and throwing whatever you're eating into that pan. I think the reasoning why, after doing the experiment, is because oil heats faster than just salt and butter. That increases the heat in the pan and forces the kernels to pop faster. When you have just salt, there's really nothing in the pan forcing the heat to rise. And that makes, not only for probably some burnt popcorn, which I found that the ones in salt didn't taste as good, first of all, but it took them way longer to pop. So, basically in conclusion, the oil in the pan conducts heat and increases the surface area of the food in contact with the heat. So it increases the heat in the pan, increases the surface area of the heat touching the food through heat energy. Therefore, the kernels are receiving increased heat from the oil or butter rather than relying on just the pan itself. So, as far as a real-world application goes, this experiment is very helpful to really anyone in the food or cooking industry, to chefs, kind of, you know, learning the science behind why things cook certain ways, why things cook faster, why things taste better. In this case, restaurants or even like movie theaters or something, they could know that the popcorn cooked in vegetable oil not only cooked much faster, but it tastes better because, one, it's vegetable oil, so it tastes better than just salt, and two, it increased the surface area of the heat in the pan, making them pop faster. So, in essence, you know, it's faster, it's great for business. You're not relying on something to take forever to cook, if you were just to put it in salt. And two, the salt came out a little bit on the burnt side, the salted popcorn with nothing else cooking. So, kind of gives you an idea. Chefs and restaurants can use information like this, not only with popcorn, but with all foods, in determining how to cook faster and with better quality. So, narrative diary for me, I just went through 16th, 17th, recorded or emailed the professor. He gave me some great tips and noted what I could use for my control variable. You go to the store. I went to the store on October 19th. Really easy. You just went to Target. Popcorn kernels were like $1 or $2. Vegetable oil was like $1. Salt and butter, $1 or $2. It's easy to, you know, keep it under like a $5 budget. It was very easy with this. 20th, I did a trial run, ate some popcorn. You can't go wrong if you're eating popcorn. 21st, did 10 trials. This is where I did each trial for each condition. 23rd, I finished the conclusion real-world application. 24th, I added pictures to the PowerPoint. And in essence, that is it for the science experiment on popcorn. So if you're interested in doing it, it's kind of a fun one to do. Plus, you get a bunch of popcorn for less than $5, so it's pretty neat. And that is all.